Hello, I'm Jay Turner, and I will be discussing my work on the validation of a method for analyzing the volatile organic compounds, or VOCs, of Mitchella repens, or partridgeberry. This work is part of an interdisciplinary project involving the biology, chemistry, earth, and environmental science departments at Worcester State to better understand the biotic and abiotic drivers of the reproductive success of this understudied native plant. Partridgeberry is found throughout eastern North America, and its reproductive success has been attributed to pollinator activity. Partridgeberry is distylous, referring to having two flower morphs, in this case the pin and thrum. The location of the style and anthers on these morphs prevent self-pollination, and both morphs must be pollinated for fertilization to occur, making the plant reliant on pollinators for reproduction. The goal of the chemical research arm of this project is to investigate the role of VOCs in pollination using solid-phase microextraction and gas chromatography-mass spectrometry to collect and analyze samples. The initial fieldwork for this project commenced in summer 2020, where VOCs were collected and analyzed on days 1 through 6 of their flowering period via GCMS. Peaks from headspace samples suggested that the quantity of VOCs might vary depending on the day of the flowering cycle. For example, the alpha-pinene peak abundance drops between days 1 and 6, suggesting that there might be less alpha-pinene in the flowers as they age. To assess these changes in relation to the day of flowering, it was important to determine the sources of the unexpected siloxane peaks. The siloxanes identified by the MS library are commonly used as adhesives and/or binding agents in industrial applications, so it was hypothesized that the SPME arrow might have scraped off some residue from the gasket on the GCMS inlet or the septa on the headspace vials. COVID-19 presented constraints to in-person research during partridgeberry's already limited flowering period between May and July, so investigation into these errant peaks was not possible during the summer. Several conditions were examined during a study of the errant peaks: a blank for baseline to see which, if any, of the siloxane peaks were already present, short exposure to a headspace vial at room temperature to assess if peaks were due to septa residue, and both long and short exposures to a headspace vial held at 50 C to assess the effects of temperature and exposure on the intensity of errant peaks. Less than 1 second was considered a short exposure and 10 minutes a long exposure. 5 runs were performed under each condition. The blank runs returned with a cyclotrisiloxane peak at 3.5 minutes, suggesting that this compound might be coming off of the GC gasket. This conclusion was further supported when the intensity of this peak did not change significantly as temperature and exposure times changed. The chromatograms from the headspace vial at room temperature showed additional intensified peaks at 18 to 23 minutes, which were identified as cyclohexa, hepta, octo, and nonosiloxanes. The long exposure at 50 C showed an additional siloxane at 13 minutes, and a drastic increase in the abundance of cyclohexa and cycloheptasiloxane. Moving forward, flower samples will be analyzed by placing them into headspace vials for exposure at room temperature to allow for more resolved terpene peaks while mitigating the intensity of siloxane peaks. The latest work on this project involved the use of a pure alpha-pinene standard to create a calibration curve from which future quantitative work could be based. A 200 parts per million alpha-pinene standard produced a peak with an abundance in the tens of millions, comparable to the abundance of alpha-pinene in the flower samples that were analyzed via headspace in summer 2020. A standard curve was produced using concentrations of 50, 100, and 200 parts per million to show the relationship between concentration and peak area. 5 microliters of the standard solution was placed into a headspace vial using a microsyringe, capped immediately, and allowed to equilibrate for 5 minutes at room temperature. The SPME fiber was exposed to the headspace for 10 minutes and promptly injected into the GC. This process was repeated 3 times for each concentration. It's unclear if the variance seen in the curve is due to an inconsistent amount of standard being delivered into the vial, the relationship being nonlinear, or some other factor. Future work for quantitation will involve direct injection to determine the relationship between the amount of volatilized standard in the headspace vial and actual amount adsorbed onto the SPME.